The night sky, when viewed from a dark and quiet place on Earth, feels full. It feels crowded. We look up and we see a tapestry of light woven so tightly that, in some places, the individual threads vanish, merging into the Milky River that gives our home galaxy its name. To the human eye, the universe is a busy place. It is a bustling metropolis of burning stars, wandering planets, and glowing clouds of gas. We feel surrounded. We feel as though we are in the thick of things, resting in a crowded arm of a spiral galaxy, which itself is part of a crowded group of galaxies dancing in the dark. But this is an illusion of perspective. It is a trick of the light, played upon us by our vantage point and the limitations of our vision. If we could step back, far back, beyond the moon, beyond the influence of the sun, beyond the edge of the Milky Way itself, the feeling of crowdedness would begin to fade. If we were to drift into the deep, intergalactic spaces, the overwhelming sensation would not be one of light, or of activity, or of presence. It would be a sensation of profound, unending silence. Tonight, we are going to explore a possibility that is as beautiful as it is humbling. It is a theory that suggests we are not just drifting in a random corner of the universe, but that we are living in a special kind of quiet. We are going to explore the idea that our galaxy and our entire local neighborhood of space is resting inside a bubble of emptiness. A vast, spherical region of the cosmos that contains far less matter, far fewer stars, and far fewer galaxies than the rest of the universe. This is the story of the giant cosmic void. It is a story about the architecture of nothingness and what it means to be alone in the dark. Let us begin by settling into the rhythm of the cosmos. Let your breath slow down to match the turning of the Earth. Imagine the ground beneath you not as a solid floor, but as the hull of a great ship, sailing through a sea that is mostly calm, mostly dark, and mostly empty. When we think of the universe, we often think of the objects within it. We think of the fiery surface of the Sun, the storms of Jupiter, or the spiral arms of Andromeda. But the defining feature of the universe is not the things that are in it. The defining feature is the space between them. The universe is defined by the void. For centuries, astronomers assumed that the universe was uniform. This is a foundational idea in cosmology, known as the cosmological principle. It suggests that, on a large enough scale, the universe looks the same everywhere. It assumes that matter stars, gas, dark matter, is spread out like butter on bread, an even, smooth distribution extending in all directions forever. It assumes that our location is nothing special. We are average observers in an average galaxy, in an average patch of density. This idea is comforting. It suggests stability. It suggests that the laws of physics and the structure of reality that we observe here are exactly the same as they would be a billion light-years away. It tells us that we are part of the common fabric of existence. But what if the butter is not spread evenly? What if there are lumps? And what if there are holes? As our telescopes have grown more powerful, peering deeper into the ancient light of the past, we have begun to construct a three-dimensional map of the cosmos. And as this map has come into focus, we have realized that the universe is not smooth at all. It is textured, it is complex, it looks less like a uniform fog and more like a biological structure. It looks like a web. In this vast cosmic web, galaxies are not scattered randomly like sand on a beach. They cling together. They cluster in tight knots and long, flowing filaments. These filaments are like highways of light, stretching across millions of light years, connecting great clusters of galaxies. This is where the action is. This is where gravity has pulled matter together over billions of years, condensing the primordial gas of the Big Bang into bright, busy regions of space. But between these filaments, between these shining highways, there are gaps. There are vast regions of space where there is almost nothing. These are the cosmic voids. They are the deserts of the universe. They are bubbles of isolation that can span hundreds of millions of light years. And the evidence is mounting that we, our Earth, our Sun, our Milky Way, are not living in one of the dense, busy filaments. We are not in the metropolitan center of the cosmos. Instead, we may be drifting near the center of one of these great deserts. We may be living in a hole in the universe, a region of underdensity that is so large it defies easy comprehension. Imagine living in a small cabin deep in a vast forest. At night, you see the lights of your own porch, and perhaps the faint glow of a neighbor a few miles away. You feel as though you are part of the world. But if you were to view the forest from above, from a satellite, you would see that your cabin is located in a massive clearing, a circle of empty grass surrounded by dense, thick woods. You live in the clearing. You live in the quiet place. That is the sensation of the local void. It implies that when we look out at the distant universe, we are looking through a window of emptiness. It changes how we measure the stars. It changes how we understand the expansion of space itself. It changes our perception of normal. Drifting through this concept requires us to let go of our human scale. A void is not simply a room without furniture. In the cosmos, a void is a region where the density of matter is significantly lower than the cosmic average. It doesn't mean there is absolute nothingness. There are still stray atoms, dark matter, and occasional dwarf galaxies drifting through the dark like lonely ships. But compared to the brilliant walls of the galaxy clusters that surround it, the void is silent. If we are indeed inside such a void, specifically one known as the KBC void, or the local hole, it would be roughly 2 billion light-years wide. 2 billion light-years of relative emptiness. The scale is staggering. To cross it at the speed of light, a speed that can circle our Earth 7 times in a single second, would take 2 billion years. It is a chasm of time and space that separates us from the denser, busier parts of creation. Why does this matter? Why does it matter if we're in a crowded room or a lonely field? It matters because gravity is the sculptor of the universe. Gravity is the force that pulls things together, and in doing so, it slows down the expansion of space. In dense regions where there is much matter, gravity is strong. It pulls and tugs, fighting against the momentum of the Big Bang, slowing the expansion down. But in a void, there is less matter. There is less gravity. The grip is looser. In a void, space is free to expand more rapidly. The fabric of the cosmos can stretch with less resistance. If we are living in a giant void, then the space immediately around us, the space we use to calibrate our measurements of the universe, is expanding faster than the space far away in the dense filaments. It creates a local bubble of speed. It means that our view of the universe is distorted by our immediate surroundings. We are looking at the cosmos through a lens of emptiness, and it creates a discrepancy in our understanding of how fast the universe is growing. This is a gentle, slow realization. It is not a crisis, but a deepening of the mystery. It suggests that our local environment is unique. It paints a picture of the Milky Way as an oasis in a desert. So, let us rest in this thought for a moment. We are floating in a galaxy that is part of a small group, the local group, which is drifting through a vast, underdense basin of the universe. We are sheltered from the gravitational turbulence of the great clusters. We are in a calm eddy of the cosmic river. The silence we find when we look up is real. The isolation is real. We are safe in our bubble, protected by distance, insulated by the void. It is a quiet place to be, a perfect place for life to evolve, undisturbed by the chaotic collisions of the dense clusters. We are the children of the void, looking out from our quiet clearing, wondering about the lights in the distant trees. To understand the void, we must first understand the structure that surrounds it. We must visualize the skeleton of the universe. Close your eyes and imagine a sponge. A natural sea sponge filled with holes and channels, tunnels and caverns. The solid parts of the sponge, the fibers that hold it together, represent the galaxies and the dark matter. The holes in the sponge, the air pockets, represent the voids. This is the cosmic web. It is the largest structure in the known universe. For a long time, we could not see this web. We were like ants crawling on a single leaf, unaware of the shape of the tree. We could only see the stars nearest to us. But as we began to map the positions of millions of galaxies, Plotting their coordinates in the dark, a pattern emerged. We saw that galaxies align themselves. They form long, glowing chains. These chains are called filaments. They are the largest known structures in existence, threads of matter stretching across the dark, billions of light-years long. They are composed of thousands of galaxies, bound together by the invisible heavy hand of dark matter. Where these filaments cross, where they intersect like the strands of a spider's web, we find the galaxy clusters. These are the nodes of the web, the great cities of the cosmos. The Coma cluster, the Virgo cluster, the Perseus cluster. These are regions of immense density, where thousands of galaxies swarm around a common center of gravity, moving at tremendous speeds bathed in hot, X-ray emitting gas. But the web is mostly empty space. The filaments are thin. The clusters are rare. The vast majority of the volume of the universe is taken up by the spaces between the threads. These are the cosmic voids. They are the dominant feature of the universe by volume. They are the great spherical bubbles that push the filaments apart. Imagine blowing bubbles into a bowl of soapy water. The water forms thin films between the bubbles. The bubbles expand, pushing against each other, creating a foam. The universe is like this cosmic foam. The galaxies live in the thin films of soap, and the voids are the air inside the bubbles. These voids are not merely empty containers. They are active participants in the evolution of the universe. They grow. Over billions of years, gravity acts like a pump. It pulls matter out of the underdense regions and flows it into the dense regions. If a region of space starts with slightly less matter than its neighbor, gravity will drain it. The matter will flow away, moving toward the stronger gravitational pull of the filaments. As the matter leaves, the void empties out. It becomes darker. And as it loses mass, its gravity weakens even further, allowing it to expand faster. The voids push the universe apart. They are the engines of isolation. We have found many of these voids in our surveys of the deep sky. There is the Boeter's Void, a terrifyingly large expanse of nothingness, 30 million light-years across. It is so empty that if the Milky Way were in the center of it, we would not have known there were other galaxies in the universe until the 1960s. The sky would have been completely black beyond our own stars. There is the supervoid in Eridanus, a cold spot in the afterglow of the Big Bang that hints at a hole spanning 1 billion light-years. But these are distant anomalies. They are places over there, far away in the deep sky. We study them with detachment. We look at them as interesting features of the map. However, the theory we are exploring today brings the anomaly home. It suggests that we are not observing the voids from the outside. It suggests that we are inside one. The evidence for this comes from the way we measure the expansion of the universe. This is the heartbeat of cosmology, the Hubble constant. It is the number that tells us how fast the universe is growing, how fast the galaxies are flying away from us. But there is a problem: attention. When we measure this rate by looking at the early universe, the light left over from the Big Bang, we get one number. It is a specific, precise speed. But when we measure the rate by looking at the local universe, by watching supernovae exploding in nearby galaxies, we get a different number. A faster number. The local universe seems to be expanding faster than the distant universe implies it should be. For years, scientists have argued over this discrepancy. Is there an error in the satellites? Is there a mistake in the math? Is there a new, unknown particle of physics interfering with the light? But the void hypothesis offers a simpler, more elegant explanation. If we are living in a giant void, a region of space with half the density of the rest of the universe, then the gravity in our neighborhood is weak. The local matter, our galaxy, Andromeda, and the nearby clusters, is not being pulled back as strongly as matter elsewhere. We are in a region of free flow. The void acts as an accelerator. The galaxies inside the void are rushing away from each other faster than the global average because there is nothing to hold them back. We are measuring a local speed limit, thinking it applies to the whole highway. This idea transforms our understanding of the Milky Way. We are not just a spiral galaxy. We are a lonely outpost. We are drifting in the middle of a grand basin, a valley in the density of the cosmos. Imagine a vast, flat plain. In the distance, there are mountains, the dense walls of the galaxy filaments. But we are here, in the middle of the plain, where the ground is flat and the horizon is far. This structure, this local whole, is vast beyond imagining. It is thought to extend for 1 billion light-years in every direction. It means that almost everything we can see with our amateur telescopes, almost every galaxy we can name, is in here with us. We are all drifting together in the same bubble. It gives a new meaning to the darkness of space. The darkness is not just the absence of light, it is the presence of the void. It is the signature of the vast, expanding emptiness that cradles us. We can imagine the filaments of the cosmic web surrounding us like the shell of an egg. We are in the yolk, or perhaps the white, suspended in the center. The walls of the shell are rich with galaxies, teeming with star formation, colliding and merging in a chaotic dance of gravity. But here, in the center, things are calmer. Things are older. Things are quieter. The void is a place of preservation. In the dense clusters, galaxies harass each other. They strip away each other's gas. They distort each other's shapes. They merge and grow into giant elliptical blobs, losing their beautiful spiral arms. But in the void, galaxies are left alone. They are allowed to keep their shape. They are allowed to retain their gas. They are allowed to form stars at their own slow, steady pace. Perhaps that is why we are here. Perhaps a void is the best place for life. A quiet, stable sanctuary where a sun can burn steadily for billions of years, and a planet can cool and oceans can form without the disruptive interference of a crowded neighborhood. As we drift deeper into this documentary, we will explore the boundaries of this void. We will look for the walls of our cage. We will try to see the edge of the bubble. And we will ask the question, if we are in a void, what does that say about the rest of the universe? What is it like out there, in the walls, where the density is high and the silence is broken? But for now, let us appreciate the space. Let us appreciate the emptiness. It is not a vacuum of meaning. It is a canvas. It is the room in which we exist. The architecture of nothingness is the architecture of our home. We are the dwellers of the deep quiet. We are the voyagers of the local whole. And as we continue, we will float toward the edge to see what lies beyond the emptiness. If you close your eyes and sit very still, you can almost feel the motion of the Earth. You can feel the hum of the planet rotating on its axis, carrying you from the light of the sun into the shadow of space. But this is only the smallest of our movements. We are passengers on a vessel that is drifting through a much larger current. We are not stationary. The Earth orbits the Sun. The Sun orbits the center of the Milky Way, and the Milky Way itself. It is moving. It is rushing through the intergalactic dark at a speed that is hard to comprehend, over 600 kilometers every second, 2 million kilometers per hour. We are racing towards something, and we are running away from something else. For decades, astronomers have been mapping this flow. They have treated the galaxies like leaves floating on a river, watching which way they drift to understand the currents beneath the surface. And for a long time, we thought we saw the destination. We saw a region of space far away, obscured by the dust of our own galaxy, that seemed to be pulling everything toward it. We called it the Great Attractor. It was a gravitational mountain, a dense knot of matter that was reeling us in. But as our maps grew more precise, we realized that the pull of the Great Attractor was not enough to explain our speed. We were moving too fast. The gravity of the mountain wasn't strong enough to account for the rush of the river. Something was missing. The answer, it turns out, was not in what was pulling us, but in what was pushing us. This is where the concept of the void transforms from a static shape into a dynamic force. A void is not just a hole, it is a repeller. Imagine a landscape with hills and valleys. If you place a ball on the side of a hill, it rolls down. Is it being pulled by the valley or pushed by the hill? In the physics of the universe, it is both. Gravity pulls matter toward the dense regions, the clusters and the filaments. But the absence of gravity in the voids creates a kind of pressure. It creates a slope. Because the void is empty, it has very little gravity to hold things back. Because the clusters are dense, they have immense gravity to pull things in. The result is a flow. Matter flows away from the void and toward the cluster. It flows from the empty places to the crowded places. In 2017, a team of scientists mapping the flows of the local universe discovered a region of space directly opposite the Great Attractor. While the attractor was pulling us, this region seemed to be pushing us away. It was a region of profound emptiness. They named it the dipole repeller. It sounds like a piece of science fiction machinery, but it is simply a name for the void. The dipole repeller is the center of the emptiness we inhabit. It is the highest point on the hill, the place we are sliding away from. This discovery changed the way we feel about our place in the cosmos. We are not just drifting aimlessly, we are surfing down a cosmic gradient. We are caught in a current that flows from the nothingness of the dipole repeller toward the density of the Shapley supercluster. We are fleeing the void. This flow confirms the existence of the giant bubble. It tells us that the emptiness is real and that it is powerful. It is the dominant force in our local history. The void has shaped the trajectory of the Milky Way for billions of years. It has nudged us gently but persistently, pushing us out of the lonely center and toward the busy walls of the cage. But this journey is slow. The universe operates on timescales that make mountains crumble like sand. We have been moving away from the center of the void for eons, yet we are still deep within it. The basin is so wide, the clearing so vast, that even at 2 million kilometers per hour, we are still in the quiet suburbs of the cosmos. There is a strange comfort in this motion. It implies a structure to reality. It implies that there is a downhill and an uphill in the universe. We are downstream. We are flowing with the current of creation, moving away from the lonely, empty origins and toward the great gathering of galaxies. But what happens to the light that travels through this valley? If we are deep in the basin looking out, how does the void affect the images we see? This brings us to the texture of reality itself. Space is not just a stage, it is a medium. When light travels through space, it interacts with the expansion of the universe. When a photon of light leaves a distant star and travels toward us, it has to cross the void. It enters the bubble. As it travels through the underdense region, the space it moves through is expanding faster than the space outside. The photon is stretched. Its wavelength is lengthened. It becomes redder. This is the redshift. It is the tool we use to measure distance and speed. But inside a void, the redshift is exaggerated. The emptiness amplifies the expansion, making things look like they are moving away faster than they really are on a global scale. It is like looking through a curved mirror. The mirror doesn't change the object, but it changes your perception of it. The void is a lens of nothingness. It magnifies the expansion. It creates an illusion of speed that envelopes us. So, when we look out at the universe, we must remember that we are looking through the atmosphere of our own bubble. We are seeing the cosmos through the filter of the local void. The Great Repeller is behind us. The Great Attractor is ahead of us, and we are in the middle, flowing down the river of gravity, trying to make sense of the stars on the banks. In the halls of modern science, there is a whisper of a crisis. It is not a crisis of catastrophe, but a crisis of understanding. It is a puzzle that keeps astronomers awake at night, a mathematical itch that cannot be scratched. It is called the Hubble tension. At its core, the Hubble tension is a disagreement between two maps. Imagine you are trying to measure the length of a bridge. You have two teams of surveyors. One team starts at the far end of the bridge and walks toward the middle, measuring every inch with a ruler. The other team starts at the near end and walks toward the middle, using a laser rangefinder. When they meet in the center, they compare their numbers. They should be the same. The bridge has a fixed length. But in the universe, the numbers don't match. The first team of surveyors looks at the early universe. They look at the cosmic microwave background, the afterglow of the Big Bang. This is the baby picture of the cosmos. By studying the patterns in this ancient light, they can calculate how fast the universe should be expanding today. They get a number, 67 kilometers per second per megaparsec. It is a precise, confident number. The second team of surveyors looks at the local universe. They look at standard candles, stars that pulse with a known brightness, and supernovae that explode with a known intensity. These are the streetlights of the galaxy. By measuring how dim these lights are, they can calculate how fast the universe is expanding right now, in our neighborhood. They get a number, 73 kilometers per second per megaparsec, 67 and 73. The difference seems small. It is only about 9%. But in a science that measures the age of the universe to the decimal point, 9% is a chasm. It is a discrepancy that screams that something is wrong. Either our understanding of the early universe is flawed, or our understanding of the local universe is flawed, or there is new physics that we haven't discovered yet. This is where the void steps in to offer a solution. If we are living inside a giant cosmic void, the local hole, then the discrepancy vanishes. It dissolves into the geometry of our situation. Remember the sponge, remember the bubble. Inside the void, there is less matter, less gravity. Therefore, inside the void, space expands faster. The first team, looking at the baby picture, is measuring the global average of the universe. They are looking at the whole sponge. They see the density of the filaments and the emptiness of the voids combined. They see the universe as it truly is on the largest scale. Their number, 67, is the speed of the deep ocean. The second team, looking at the local stars, is measuring the expansion inside our bubble. They are measuring the speed of the water in our specific eddy. Because we are in a void, the local gravity is weak and the local expansion is fast. Their number, 73, is the speed of the current in our lonely river. We are measuring the local weather and mistaking it for the global climate. The crisis is not a failure of physics, it is a failure of geography. We assumed we were in a normal place. We assumed we were average. But the universe is telling us that we are special. We are in a fast lane. We are in a pocket of low density that distorts our view of the wider world. This realization is soft, but it is profound. It suggests that our measurements are correct, but our context was wrong. The universe is 67, but our neighborhood is 73. Both truths can exist at the same time, as long as we acknowledge the walls of the void. There is a specific study, led by astronomers Keenan, Barger, and Cowie, that mapped the density of the universe around us. They counted the galaxies, layer by layer, moving outward from the Milky Way. They found that the density of galaxies stays low, surprisingly low, for 1 billion light-years. Only when you get past that mark does the density rise up to the cosmic average. It is like walking out of a valley. For miles, the ground is low. Then, finally, you hit the foothills, and then the mountains. We are deep in the valley. The light from the distant supernovae has to travel down into our valley to reach us, and in doing so, it traverses the fast expanding space of the void. This doesn't mean the Big Bang didn't happen. It doesn't mean dark energy isn't real. It simply means that we need to calibrate our instruments to account for our address. We live at one cosmic void lane. Think of the psychological shift this requires. For so long, science has tried to dethrone humanity. We learned that Earth is not the center of the solar system. We learned that the Sun is not the center of the galaxy. We learned that the galaxy is not the center of the universe. We have been pushing ourselves further and further into mediocrity, convinced that there is nothing special about where we are. But the void hypothesis pushes back, just a little. It says, you are not in the center, but you are in a unique spot. You are in a quiet spot. You are in a place where the universe has been cleared out, swept clean by the broom of gravity, leaving a wide, open space for you to observe the stars. It is a privilege to be here. If we were in the center of the Coma cluster, surrounded by thousands of swarming galaxies, the night sky would be blazing with light. The radiation would be intense. The gravitational tides would be violent. We might not have survived to build telescopes. But here, in the KBC void, The sky is dark. The neighbors are distant. The expansion is fast and smooth. We have been given a front row seat to the expansion of the universe provided by the very emptiness that isolates us. And so, the tension of the Hubble constant becomes a clue. It is a breadcrumb trail leading us to the realization of our container. The numbers don't match because the environment is distinct. The crisis of light is actually a map. It is drawing the boundaries of our bubble. As we move toward the final chapter of our journey, we must ask, if this void is our home, how long will it last? What is the future of a bubble in a boiling ocean? And what does it mean for the ultimate fate of the Milky Way to be drifting alone in the dark? We have explored the neighborhood. We have explored the architecture. We have measured the speed of the shadows. Now we must turn our eyes to the future and to the philosophical quiet that comes with knowing we are truly, deeply alone. The universe is a story of flow. Nothing stands still. The stars burn, the galaxies spin, and the void grows. As we look forward into the deep future of the cosmos, the void becomes the main character. It is the void that will determine the final shape of the sky. We know that the universe is not just expanding, it is accelerating. A mysterious force, dark energy, is pushing space apart. It is inflating the voids, stretching the bubbles of the sponge until the filaments snap. In the distant future, the voids will merge. The small bubbles will join to form supervoids, and the supervoids will join to form an ocean of emptiness, so vast that the galaxies will seem like lonely specks of dust separated by infinities. For us, inside the KBC void, this acceleration has a profound implication. The walls of our cage, the dense filaments of the Perseus, Pisces supercluster, the Coma Wall, the distant mountains of light are moving away from us. They are being carried by the flow of the expansion. One day, they will cross a line. It is a boundary known as the cosmic horizon. It is the point of no return. Beyond this horizon, space is expanding faster than the speed of light. Any light emitted by a galaxy beyond this line will never reach us. It will be forever outrunning the expansion, trying to swim upstream in a river that is moving too fast. Slowly, over billions of years, the lights on the horizon will wink out. The distant clusters will fade. The glowing web will disappear from view. The universe will grow dark. Eventually, if the expansion continues, the Milky Way and its nearest neighbors, Andromeda and the dwarf galaxies of the local group, will be the only things left in the sky. We will be an island universe. Future astronomers, born 10 billion years from now, will look up and see a sky filled with stars, but those stars will all belong to our own galaxy. They will point their telescopes into the deep dark, searching for other galaxies, for the cosmic web, for the Big Bang. But they will see nothing. The void will have grown so large and the expansion so fast that the rest of the universe will be erased from the sky. They will believe that the Milky Way is the entire universe. They will believe that space is static and eternal. They will have no evidence of the expansion, no evidence of the web, no evidence of the great bubbles of the past. We are living in a golden age of cosmology. We are living in the brief window of time where the void is large enough to shelter us, but small enough that we can still see the walls. We can still see the other galaxies. We can still see the history of the cosmos written in the light of the clusters. We are the witnesses. We are the only ones who will ever know the true shape of the sponge. This thought brings a deep, resonant peace. It reframes our isolation. We are not trapped in a hole, we are cradled in a clearing. The void is not a prison, it is a sanctuary. Imagine the alternative. If we lived in a dense cluster amidst the chaos of colliding galaxies and blazing quasars, we might never have had the stability to look up and wonder. The radiation might have sterilized our planet. The gravitational disruptions might have flung us into the cold dark. But here, in the quiet, we have thrived. The void has given us safe harbor. It has given us the time to evolve, the silence to think, and the darkness to see. Perhaps this is the ultimate purpose of the void, not to separate us, but to protect us, to create a pocket of calm in a violent universe where life can take hold and consciousness can wake up. We often fear the dark. We fear the empty spaces. We fill our lives with noise and light because silence feels like absence. But the cosmos teaches us a different lesson. It teaches us that the void is necessary. The void is the space where things happen. It is the canvas upon which the galaxy is painted. Without the empty space between the notes, there is no music. Without the empty space between the stars, there is no light. Without the giant cosmic void, there is no us. So, tonight, when you step outside and look up at the sky, do not look for the stars. Look for the space between them. Look into the black velvet of the night. You are looking into the face of the void. It is vast, it is ancient, and it is expanding. It is the reason we are here. We are floating in a giant bubble of silence, drifting down a river of gravity, surfing the waves of nothingness. And in all that emptiness, in all that vast, lonely dark, we have found a way to shine. We are the light in the void. We are the awareness in the empty room. And for as long as the stars burn, we will be the watchers of the quiet. Sleep well in the safety of the deep, dark calm. The universe is vast. But here, in our bubble, we are home.